All right. After learning a lot about how blockchain agents can work in agentic commerce, now it's time that we shift gears a little bit towards verifiability, especially when it comes to AI agents and intents. Today, we have with us Kwame Bryan, who will be presenting ERC-8001. The cool thing is that he himself is the author of it. So if you have any questions related to this particular ERC, keep your questions ready for the end, and we'll obviously bring them up on stage. Kwame, are you ready? Over to you.
Hello. My name is Kwame. I'm an independent EIP author. I wrote ERC-8001. It became a standard ERC in December of last year, and I'm hoping to just give you guys an introduction to what we're trying to do. So basically, if you kind of look at it, like everything needs coordination, and ERC-8001 is built to standardize how agents, protocols coordinate on chain. And if you kind of look at it at the broad scope of how the agentic commerce works, you would have 8001 for coordination. 8004 would handle like identity registry, and then you would have X402 for payments. So every transaction that we've ever done has required some kind of coordination. If we look at desk swaps, lending, yield farming, voting on a DAO, game movement. My background is in blockchain games, tasks for agents, bridges, or multi-signature. There's all some kind of coordination, and somewhere, somehow, either on a back end or some man in the middle, someone had to sequence, someone had to verify, and settle one of these in one of these steps. So what does the current coordination framework look like right now? Well, basically it's ad hoc, it's fragmented, and we have to put a lot of trust assumptions into it. And the further we go with agentic commerce, humans are going to be outside of this loop. We're not going to be in the middle. Agents are going to be coordinating on their own. They're going to be signing their own transactions. They're going to be managing their own wallets, and they're going to be managing their own tasks. So every protocol has coordination. This is nothing new. But if you wanted to do something with Uniswap, Aave, Compound, each has their own bespoke way of handling coordination logic, and none of it composes. So if I was an AI agent and I wanted to do things between Aave, Compound, or Morpho, or something like that, there is no standardized way for it to do it. And different agents wouldn't be able to coordinate together in order to do some of these agentic commerce tasks. If we want to look at a multi-party, a trusted intermediary, say we have 3 agents that need to act together, now we have to add in a trust assumption like a relayer or some kind of centralized service to broker this idea. On the third part, we have no standard proof of agreement. So if 2 agents agree to coordinate, there's no on-chain proof. And if there is a dispute, they're not resolvable. So if we look at 8004 on its own, what if these agents don't agree? What if there is something that goes wrong? There's no way to dispute this. It's basically the funds are transferred from one agent to the next, and there's no recourse from that. Now, this whole idea of 8001 and the coordination framework is based on intents. And there are standards like 7521 and 7683, and these were great for single initiator flows. But in the world of agentic commerce, we have multiple agents that are working, that agree, that coordinate, and multi-party coordination was the main reason why we designed this standard. Taking it back a little bit, we do a lot of blockchain games, and we have these agentic NPCs that were programmed to know their environment. They were programmed to know the distance between a player and the agent itself and to be able to change their state. But once we started giving them their wallets and working with things like 6551 and a lot of our games, and they had their own ways of being able to do different things, we came to this whole idea of, well, they can do this on their own, but what if they want to communicate with a player? Or on a grander scheme, what if agents or NPCs wanted to coordinate on their own, or to do a swarm, or sell items, or to maybe help a game player out? Like, how do you solve those types of problems? And 8001 was our idea of doing it. So we're very grateful to the standards that had done the single initiator flows, because if it wasn't for these particular standards, we wouldn't have been able to build upon it and do 8001. So where does coordination break down? Well, anywhere where you want to coordinate something. Say in a yield strategy, you have 3 agents that want to rebalance between Aave, Morpho, and Comp simultaneously. Currently, right now, what happens is that an agent would basically broadcast this out, and then we would hope that these other agents kind of follow suit. We have no idea if they do. Most of the times they don't, unless you have some kind of intermediary that is, hand-holding a lot of this stuff. So currently within the blockchain space, we have a lot of trust assumptions, and we are handing off a lot of trust to servers that are holding private keys to do these middle grounds. Now, in the agentic commerce world, if a server broke down that's holding this EOA, this whole flow would basically end, and these on-chain transactions wouldn't exist. Cross-protocol liquidation. Here we have Liquidator, the Oracle settlement agent, must act in lockstep. Today, we have custom off-chain messages, which is kind of the standard right now. We have race conditions that basically come up, and then we have MEV at every step. Billions of dollars are currently being lost to MEV. Now, I'll be totally honest and upfront. ERC-8001 does not solve MEV. We don't claim to. What we do is mitigate it, because 8001 has a base coordination layer, and then the standard itself has adapters. It's based on modules. So you can add a privacy module that would help with MEV. You can add all different types of modules to handle anything that you want. So if you look at the standard, which is final at this point, it goes over that. DAO multisig. Now, I do love Gnosis. I use Gnosis. Everyone here uses Gnosis. But it's a single initiator flow. What if you wanted to add extensions on top of how Gnosis does things? You currently can't do that. By integrating 8001, that gives you this ability. So instead of thinking of a world currently in Ethereum where we are just talking about transactions, we are now thinking of a new programming paradigm within Ethereum where transactions are driven by intent and not by an actual transaction construction itself. So, gaming, which is our background, you have 4 players that commit moves in a turn-based game. Today, the game server basically decides the order, and players trust the server. And if you look at the history of Ethereum, the reason why Vitalik came up with Ethereum itself was with a WoW, World of Warcraft, and losing his assets. So taking into account ERC-8001 basically solves this as well. So the reason of this talk, ERC-8001, it's named the Agent Coordination Framework. Now, when we started thinking about what an agent was, everyone here that communicates or interacts with a Web3 wallet is an agent. The difference between an AI agent and an agent like ourselves is that an AI agent has its intelligence through like an LLM. But anybody who interacts with the blockchain is an actual agent. And that's a very important thing to remind ourselves, because as we get into this agentic forward-thinking world, humans and agents are going to be working, transacting, and communicating and coordinating all together. So there's not going to be a real differentiation between something that is an agent that is powered by an LLM and an agent that is powered by good old human creativity and imagination. So how is this basically broken down? At its core, it's minimal. It's a single chain primitive with multi-party coordination. An initiator proposes an intent. So if you think of an intent like we're here at ETHDenver, you meet up with someone that has a great idea, you guys want to talk about business. The coordination is, hey, let's meet after this talk at this booth in 30 minutes. That's the intent. The proposer initiates this intent, and then there may be a group of agents or people that agree to this. They all sign their attestation. So the first intent is an attestation that's signed by the initiator. All the parties that want to agree sign their version of that agreement. And after that, all the people who are coordinating have signed, then that is be ready, and then it can be basically executed. So for the type data, we use EIP-712. Everybody is familiar with that. When you sign a transaction and you actually see exactly what you are signing, that is EIP-712. We use smart wallets because agents work really well with smart wallets. And it's not to take away from anything else, but we all know that there's an EOA somewhere when we're dealing with this stuff. We have monotonic nonces, which just means that there's always a unique nonce, so for protecting against replay and things like that. It's modular by design, so you can add any other type of primitive, trust, registry, which we are currently using 8004 for registry, but say you want to do trust, or you wanted to do privacy modules, you can extend and add that as an extension on top of ERC-8001. So we designed the whole core of 8001 being forward thinking, because we just don't know what's going to happen in the future, but we do know that there's going to be a base component that is never going to change. And it's MEV resistant. It doesn't stop MEV whatsoever. And MEV, there is good parts to MEV, which there might be some backlash to that, but it keeps the blockchain honest, and it keeps the developers who are doing things honest as well. So there's three main components to how ERC-8001. There's the propose. As I talked about earlier, you propose the intent. That is kind of like the agreement. The acceptance part is where all the agents, either powered by LLMs or by humans themselves, accept this. And after everyone has signed their portion of this agreement, it becomes executable, and then it can be executed. There's four main kind of components or stages of it. There is none, there is a proposed, ready, and then executed. So the standard itself is really, really simple, and is meant to be really, really simple. There should not be a huge amount of complication to coordinate operations on chain. So here's the three primitives, but it's one standard. We have the agent intent. As we mentioned before, an initiator signs the type data intent, specifying the coordination type. This could be, going out for lunch, or the actual agreement or contract itself. The participants are sorted uniquely. There is the expiry, or how long this intent should last for, and then an opaque payload hash. And then you have some of the properties that are a part of this, and we have another slide that shows us as well. So you have the payload hash, the expiry, the nonce, the agent ID, which if you're familiar with 8004, that's kind of tied into it, the coordination type, and then the participants. Then we have the acceptance attestation. So each participant signs their own version of this. So you have the initiator who says, this is what we are planning to do. And then each of the participants sign their version of this agreement. And it references that intent. And when all accept it, the intent is ready for execution. And then there's the intent hash, the participant, the nonce expiry, the condition hash, and then, of course, the signature. And then we have the coordination payload. This is the actual coordination data itself. It's opaque to the core. And at execution, the payload must hash to the payload hash, and your DeFi strategy, your game move, or agent task list here, or however you want to basically define it. So you have the version, the coordination type, the coordination data, the coordination hash, and additional metadata if you want to have that associated with it. Okay, so this is the hello world version of how ERC-8001 works. It's very, very simple. The interface, you have the proposed intent, you have your coordination payload, and the signature. We have the accept intent, which has the intent hash and the call data. And then we have the function for the execute coordination, which has an intent hash, the coordination data, and then some call data as well if you want to have that associated with it. The second part here is the actual coordination payload. The first part is the coordination type, which really defines what we are coordinating. We have the participants who must agree. We have, Alice and Bob here, but this could be, a group of people. We have the coordination data. Here we just have hello world, but this could be a game move. This could be a DeFi strategy. This could be basically whatever you want it to be. We have the unique nonce, which is going to be incremented to prevent replay. And then we have the deadline, which is the expiry. So in step one, we have Alice proposes. We have the coordination type, which is the greeting type. We have our participants, which are Alice and Bob. We ABI encode hello world. The nonce here is 1. And then we have the block timestamp. And then we have our proposed intent with the payload and Alice's signature. Now, me as Bob, I'm the one who's agreeing to this or wanting to interact with it. I accept this intent, and I sign my version of that. This is now proposed already. All participants have signed. And then at this point, anybody can execute. And then we have the result here, which is the get greeting, and it would be hello world from Alice and Bob, their addresses. So the key insight here is that each party's cryptographically agreed before executing. Either both signatures are valid to execute or nothing happens. There's no trusted intermediary needed. We don't need a server. We don't need any other outside things because the intent is the agreement. That is what we're signing. And if we agree to that, then we can execute this transaction. So if you want to take it a bit further, you can kind of look at it as like an atomic swap would be advanced part of the hello world here. And a complete audit trail is here and who agreed to what and what they agreed to. So we came up with 8001, and it was an agent coordination framework, and we were really stoked about the work that the team at 8004 has worked on, because it kind of added the extended layer that our small team wouldn't be able to do. So here we have the Discover agent, a reputation with 8004, propose the coordination with 8001, the participants accept with 8001, we execute with either 8001 or 4337, settle the payment with X402, and then post feedback back with ERC-8004. So everything needs coordination. Now there's a standard. We have 8001 on Ethereum, SIP 037 as a coordination standard on Stacks. We have our SDK that you can get just from NPM. Our smart contracts are available on our GitHub. It has an atomic swap. It also has a bounded execution example as well. And we're currently working with the ENS team to do the ERC-8107, which is the ENS Trust Registry. Get involved on Ethereum Magicians. It's still in the early stages. And my name is Kwame. This is ERC-8001. And thank you for ETHDenver for allowing us to be here. That's it. Thank you.